Hello children, today we will start our discussion from enthalpy of hydration. So according to definition, it is a change in enthalpy when 1 mole of an anhydrous salt combines with required number of water molecules and gets converted into hydrated salt. So it is always negative. Change in enthalpy of hydration is always negative, means hydration is a exothermic reaction. Hydration is a exothermic reaction. Okay students, so for example, when anhydrous copper sulfate is get combined with 5 molecules of water, then it converted in the form of copper sulfate pentahydrate, and the enthalpy change is minus 78 kilojoule per mole, which is known as enthalpy of hydration. Okay students, the next is enthalpy of solution. So according to definition of enthalpy of solution, it is the change in enthalpy when 1 mole of the substance is dissolved in a given amount of the given solvent. If the volume of the solution is so large that further dilution of the solution does not produce any heat change, then it is called enthalpy of solution. Okay students, so it means that when we are dissolving 1 mole of the substance in such amount of solvent that on further dilution no change in heat, so that amount of enthalpy change is known as enthalpy of solution. Okay students, and this enthalpy of solution is maybe positive or negative. So enthalpy of solution, or you can say dissolution of any substance in a particular solvent, can be exothermic or endothermic reaction. Okay students, the next enthalpy type is lattice enthalpy, and this term is very important for you, lattice enthalpy. So according to definition, it is defined as the change in enthalpy when 1 mole of an ionic compound dissociates into its ion in gaseous state. Or in reverse way, you can say that when free gaseous ions are taken in the form of 1 mole of the substance, then the change in enthalpy is taking place will be known as lattice enthalpy. Okay, so 1 mole of solid is converted in the form of its gaseous ions, or gaseous ions converted in the form of 1 mole of the solid. Okay, in both the cases, the change in enthalpy will be considered as enthalpy change in lattice or lattice enthalpy. Okay students, the next is enthalpy of atomization. So enthalpy of atomization is the change in enthalpy when 1 mole of a given substance gets converted into gaseous atoms. So solid or gas, when converted in the form of gaseous atom or free atom, so the change in enthalpy is known as enthalpy of atomization. Okay students, atomization, enthalpy of atomization. The next we will discuss very important heading, Hess law of constant heat summation. It is a very important law, Hess law of constant heat summation. Okay, and definition: change in enthalpy of a reaction is same whether the reaction is carried out in one step or in several steps. So change in enthalpy will be remain constant, where this change can be done in one step or in number of steps. But in both the conditions, the change in enthalpy will remain constant. This is Hess law, which is also known as constant heat summation law. Okay, students. So if you consider a chemical change in which A is converted in the form of B directly in one step, and let the enthalpy change is delta H1. Okay, now same conversion we are doing in number of sub steps. Okay, so what we are having, we are going to convert A to B as we have done here. So enthalpy change is delta H1. But if the same change we are doing in number of steps, and let when A is converted in C, change in enthalpy is delta H2. When C is converted in D, change in enthalpy is delta 3. And in last, D is converted in the form of B. And here the change in enthalpy is delta H4. So according to Hess law, the change in enthalpy in these both the cases will be equal or same. Okay, so it means delta H1 will be equals to delta H2 plus delta H3 plus delta H4. So this is according to Hess law. Okay, students. Or you can take an example which is related with our daily life. We most of the time we prepare tea in kitchen. So preparation of tea we can do in two ways. According to first way, all the ingredients related to tea we add at once together. Okay, and in second way, we just warm up or boiled water and milk separately, and then we add water plus milk plus sugar and tea leaves for the formation of tea with the help of tea bag. Okay, so this is the second way for the formation of tea, and this is the first way where we are mixing all the ingredients together in boiling water, and after that we will filter it. Okay, so there are two ways. According to Hess law, in both the cases the total heat change or total enthalpy change will be same. Okay, students. Next heading is applications of Hess law. First, with the help of Hess law, we can calculate enthalpy of those reactions whose enthalpy cannot be determined experimentally. Okay, so with the help of given data, we can calculate enthalpy change of such reactions also which cannot be determined experimentally. Second point, Hess law is used to calculate enthalpy of formation, enthalpy of combustion, enthalpy of transformation and reaction also. So on the point of view of numerical problems, this Hess law is going to be very important for all the time. Okay, students. So you have to do a lot of practice for the numericals which are based on the Hess law. Okay, it is used to calculate bond energies also. Bond energies. Okay, so bond energy or bond dissociation enthalpy, mean bond enthalpy. So for the bond energy we use two terms, bond dissociation enthalpy and mean bond enthalpy. So bond dissociation enthalpy, first heading. So according to definition, the energy required to break 1 mole of same type of bonds. 1 mole of same type of bonds. For example, if you are taken 1 mole of hydrogen and you converted it in the form of 2H, mean free atoms, then the change in enthalpy will be known as bond dissociation enthalpy or simply bond energy. Okay, students. In second case, HCl is there 1 mole and it's converted in the form of free atoms. So the change in enthalpy will be dissociation enthalpy, bond dissociation enthalpy. Now for the polyatomic molecules like CH4, NH3, okay students, in all such molecules, all the bonds which are present here, carbon is carrying 4 CH bonds around it and nitrogen is carrying 3 nitrogen-hydrogen bond around it. Okay, so in such polyatomic molecules, all the bonds are not carrying similar amount of energy. Okay, so that is why we will consider their mean bond enthalpy. Okay, so for such compounds, average of the bond dissociation energies is taken and this average is equal to the mean bond enthalpy. Okay, so we will calculate all the bond energies of the related different bonds and then we will find out average energy change. For example, in H2O molecule, as you can see here, H2O, so these two HO bonds are not having same amount of energy. So we will calculate first this enthalpy change and in second this enthalpy change and then we will take average of these two. So this is the mean bond enthalpy. Okay students, the next heading is for diatomic molecules like chlorine, hydrogen, oxygen, nitrogen, mean bond enthalpy is equal to bond dissociation enthalpy. Now, what is the use of bond enthalpy data? It can be used to determine delta H of the reaction, means enthalpy change, and to calculate the bond energy of given bond. And this is the relation for the bond energy. Enthalpy change will be equals to sum of bond energies of the reactant minus sum of the bond energies of the product. Okay, and this relation is valid when reactants and products are in gaseous state only. Now next heading, some facts about the bond energy. So some facts are repeated here again. In CH4, the bond dissociation energy of all the bonds are not equal. So that is why we will take mean bond enthalpy for such compounds. In CH4, all C4CH bond energies will be equals to the total of bond energies of different CH bond divided by 4. So mean bond energy. Okay, next point. Bond enthalpies are used to calculate the enthalpy of formation of compounds. Then, very important point, smaller the bond length, greater is the bond energy. We all know this point. Then fifth point, bond energy is the double of a double bond or triple bond is greater than that of single bond. Okay, so CC single bond with least energy, double bond more, and triple bond highest energy. Okay, so least, higher, highest. Then sixth point, enthalpy of reaction is equal to sum of bond energies of reactants minus sum of bond energies of products. You can use this relation. Then examples are given related to enthalpy of reaction, and after this exercise question for practice. You have to do these questions. Then solved numerical problems based on Hess law, and these problems are going to very important for you. Okay students, so you have to just go through with these problems, and after this related exercise is given for you. One exercise is given for you, so you have to solve this exercise also, which is based on Hess law.